Hello and welcome. In this video, we're going to talk about reducing fractions. So to reduce a fraction is to write it in the simplest possible way. Now we're going to start with the fraction 8 over 20. Now the goal is to find a common factor of the numerator, that's the number on the top, and denominator, that's the number on the bottom. So we're looking for a number that both of these numbers can be divided by. So both 8 and 20 are even numbers. So you could probably see right away that a factor of both 8 and 20 is 2, since they can both be divided by 2. Also, you can probably see right away that both numerator and denominator can be divided by 4. So that means 4 is also a factor of 8 and 20. Therefore, both 8 and 20 can be divided by 4. Now, 2 is the smallest factor that 8 and 20 can be divided by. We call this the least common factor, or LCF for short. And 4 happens to be the largest number that both 8 and 20 can be divided by. So we call this the highest common factor, or HCF for short. Now you could choose to reduce your fraction using any of these factors. We're going to start with 4 first, the highest common factor. So 8 divided by 4 and 20 divided by 4. 8 divided by 4 is 2, and 20 divided by 4 is 5. So now we've reduced our fraction to its simplest form. It cannot be reduced any further because both 2 and 5 do not share common factors. Now let's try reducing the fraction using the least common factor, 2. So we're going to divide 8 by 2 and 20 by 2. 8 divided by 2 is 4, and 20 divided by 2 is 10. So we see by using the least common factor that we are going to need to continue reducing our fraction, because we can see here that this fraction can still be reduced because both 4 and 10 have common factors, all right? And also we can see that 4 and 10 are even numbers. So let's use 2 as our common factor that we're going to use to reduce this fraction. So 4 divided by 2 is 2, and 10 divided by 2 is 5. So as you can see, we get the same answer as we got when we use the highest common factor. The only difference is using the largest number or the highest common factor helped us to reach our simplest form a lot quicker. I'm going to show you a method for reducing fractions, and this method involves prime factorization. We're going to use a tree diagram to find the prime factors of the numerator and denominator of this fraction, starting with 12 and then 42. So we're going to create a tree diagram and ask ourselves, what two numbers can we multiply together to equal 12? Well, we can use 2 multiplied by 6. And now we need to check to see if we have any prime numbers between these two factors. Well, what are prime numbers? Remember, prime numbers are numbers that can only be divided by itself and 1. So there are only 2 factors. So 2 can only be divided by 2 and 1. So that makes it a prime number. So we're going to circle it. Now 6 has more than 2 factors. It can be divided by 6, by 1, by 2, and by 3. So we're not quite done here yet. So let's create branches for the number 6. So two numbers that can be multiplied together to equal 6 are 2 and 3. So as we already stated, 2 is a prime number, so we're going to circle 2. And 3 only has 2 factors as well, itself and 1, so we're going to circle 3. So the prime factorization for 12 is 2 multiplied by 2 multiplied by 3. So let's put the prime factorization beside the numerator 12. Next, 42. Two numbers that can be multiplied together to equal 2 are 2 and 21. Again, 2 is a prime number, so we're going to go ahead and circle that one. 21, on the other hand, has multiple factors. So two numbers that we can multiply together to equal 21 are 3 and 7. And again, 3 is a prime number, and 7 only has two factors as well, so it's a prime number as well. So the prime factorization of 42 is 2 multiplied by 3 multiplied by 7. So let's place the prime factorization of 42 next to 42. So now that we have the prime factorization of both numerator and denominator, we're going to eliminate any factor that matches on the top and bottom. So on the top and on the bottom, we have two factors that match, and that's the number 2. So let's eliminate those two numbers. Next, on the top and bottom, we also have two more factors that match, and that is 3 and 3. So let's eliminate those. So now that we've eliminated those, anything that remains is going to go into our fraction. So 2 remains on the top, so it's going to be our numerator. 7 remains on the bottom, it's going to go into our denominator. So 12 over 42 reduced is 2 over 7. Okay, let's try one more. This time, 45 over 81. So we're going to find the prime factorization of the numerator and the denominator. So let's create a tree diagram to help us track our factoring steps. So two numbers that we multiply to equal 45 are 5 and 9. And 5 is a prime number because it can only be divided by itself and 1. Two numbers that we can multiply together to equal 9 are 3 multiplied by 3. So those are the only two numbers that we can multiply together to give us 9. So we have the prime factorization of 45, and that's 3 multiplied by 3 multiplied by 5. And next, 81. So two numbers that can multiply together to equal 81 are 9 multiplied by 9. All right, so both factors are the same. So the tree diagrams that we create for both of these are going to give us the same results. 3 multiplied by 3 equals 9, and 3 is a prime number. And again, 3 multiplied by 3 is 9. So we're going to circle all of our 3's. The prime factorization of 81 is 3 multiplied by 3 multiplied by 3 multiplied by 3. So now let's cancel out any factors that match on the top and the bottom. So we have 3 on the top and 3 on the bottom. They match. We also have another match with 3 on the top and 3 on the bottom. So let's cancel those out as well. So now we don't have any more factors that match between the top and the bottom. So the numerator for our fraction is going to be 5. And denominator, we're going to multiply the remaining factors on the bottom. 3 multiplied by 3 is equal to 9. As always, thank you for watching this video, and I'll see you in the next one.